Today we're talking about osmosis, which is the transporting of material between two solutions through a semi-permeable membrane. You're going, what the heck is that? Okay, well this happens in pickles, baking of pickles, this happens in your kidneys, this happens in plant cells, it happens in water purification systems. Osmosis. What happens, and in all these cases there is a semi-permeable membrane. That means some things permeate through the membrane. Some things can come out, some things can go in. In your kidneys, some things can go in, some things can go out. In the pickles, in and out. So that's a semi-permeable membrane. All of these things have them. And material is going to be transported on either side of that membrane. Now, before we can really understand what's happening and observe it, because we're going to do a lab to observe osmosis, we need to know some terminology about these solutions. Terminology is hypotonic, isotonic, and hypertonic, and all of these words are in reference to the solution. We're going to start with isotonic. If you look at the picture here representing isotonic, you will see that both solutions are of the same, that's what iso means, same concentration. So on either side of that semi-permeable membrane, this membrane right here, that could be the edge of a pickle, this could be the edge of a plant cell, this could be the wall of your kidney. On either side of that semi-permeable membrane, the concentration is the same on either side. That makes it isotonic. The word hypertonic, think of the word hyperactive. Hypertonic means there is a high concentration on one side of the membrane. In this case, there is the high concentration side, and inside our cell is the low concentration side. So hypertonic means it's hyper on the outside of that membrane, as opposed to hypo, which means low. So there's a low concentration on one side of the membrane. Again, if this is our wall of our cell, there is a low concentration versus a high concentration of particles on either side of that membrane. So there's three terminologies we need to know. Now, what happens to my cell in these situations? Well, some bad things can happen and some good things can happen. Give you a second to look at the pictures. The top picture up here would be a plant cell. Down here would be our blood cells. This would be if it was in the lab, which we're going to do today, where this is our semi-permeable membrane. Maybe this is a pickle. Maybe this is the skin of a pickle. Which way does the material flow? And if you look at the blood cells, that's probably the easiest one to look at. In an isotonic solution, meaning if the blood is sitting in a solution that's the same outside the cell and inside the cell, the concentration is the same, isotonic, the cell remains relatively normal. But if the cell looks as though it's shriveling up, that's because the cell is sitting in a hypertonic solution. There is too high of a concentration here, too low of a concentration on the inside, and the water tries to leave. Water leaves the cell in that situation, and the cell shrivels up. As opposed to a hypotonic situation where the outside is too low of a concentration, so the water actually enters into the cell and the cell swells up and bursts. This is not good if you are a blood cell. If you're a plant cell, it's not too bad, because if the plant cell swells up, if the water goes in it because there's a low concentration on the outside compared to the inside is a high concentration, then the plant swells up and is nice and sturdy and strong. The plant will wilt. This is a wilting plant. If it is a hyper situation, where on the outside is too high of a concentration and on the inside it's low, the water will try and leave the plant and the plant will start to wilt. The water will always flow into the more concentrated environment every time. So in the case down here, the left side is more concentrated than the right side. So if this is my pickle or a carrot or a kidney, what's going to happen is the water will flow into the more concentrated side, so the water will flow this direction. This side will shrivel, get smaller, and this side will fatten up, will get fatter. So depending on if it's a carrot, the carrot might swell up, or if it's a pickle, the pickle might shrivel up depending upon what kind of solution we are in. It's easiest to see this firsthand, and we're going to do that in a lab.